Hey, this is Vanna from DevRel at GraphGrid. Welcome to the second video of our tutorial series, Search Basics. This tutorial follows the movie database tutorial. So if you haven't seen the first video, pause this and come back once you have. The first video walks through creating the movie graph and dashboard configurations that we'll be using for this tutorial. And if you've already done the movie database tutorial, hopefully you've also already set up your shell variables. If not, we have a video for that too, as well as a doc site with written instructions and tutorials. You can find links to these resources in the description of this video. Before we start, let's go over a few key terms. Indexing, the process of putting data into Elasticsearch so it becomes searchable. Searching, the process of retrieving data from Elasticsearch through a query. Elasticsearch index, a logical namespace which holds documents. Elasticsearch document, a searchable unit containing properties. To start things off, we'll design features for search functionality. First, we'll decide what information we want to make searchable. This step will inform us how to use and design our index policies and search queries. Then we'll work on indexing. We'll generate and customize an index policy that we'll use to index our nodes on the graph. Then we'll talk about event-driven indexing, also known as continuous indexing. Let's think about what features we want search to have so that we can design our index policy around them. A good first step is to ask yourself some questions about your design. Simple questions like what do we want to search for, who's the intended user, and how are they going to use this. For this tutorial, we'll be implementing two different features. Our first feature is that every person and movie node should be searchable by their node properties. The second feature is that searching a title of a movie like The Matrix should return that movie along with all the associated people. So our next step is to index our data. Indexing is an operation that transforms graph data into a searchable text. The goal is to move the information from ONgDB over to Elasticsearch. We do this by making an index policy. The index policy tells the module how to move that data. The index policy is a JSON document that defines what information in ONgDB to index and how to get that information. Core sections of the policy define schema, or the mapping from a node to an Elasticsearch document. Since policies follow a predefined structure, these definitions can be applied to any graph. So what we'll do is generate an index policy. Generated index policies provide out-of-the-box searching for node properties. This feature generates a separate index for each desired node label and creates a template that the user can customize. They also provide basic search functionality. One of these functions is the ability to search for a node's properties. By default, the generated policies define common properties to be indexed. You can generate a policy for all node labels or for a specific subset. When generating the index policy, search assumes that the data on the graph has consistent property typing. Let's revisit feature 1. From what we know about generated index policies, we can set the policy schema for specific node labels and their properties. This means that we can meet feature 1 by generating an index policy specifically for person and movie node labels. If you're following along with the search tutorial on the doc site, you can copy and paste this curl command directly into your terminal. The request will return our generated index policy. Next, we need to save the index policy. This is done by passing the generated index policy in the body of the save index policy request. Using the search tutorial on the doc site, we can copy the save index policy request and paste it into our terminal. Now that the index policy is saved, we can operationally index our data. An index policy is just a file, so by itself it doesn't do anything. You can think of the index policy like a set of instructions on how to index your data. Search and Elasticsearch work together to follow these instructions after you tell them when to operate. There are two methods to invoke indexing: manually through indexing endpoints or setup of event-driven indexing, also known as continuous indexing. To meet feature 1, we'll index our data manually using indexing endpoints. Search uses broker-based indexing with the default broker RabbitMQ, so failed indexing messages are sent to a failure queue in the broker so there is no data loss. There are two manual indexing options: full indexing and partial indexing. Full indexing indexes all nodes and can also be used to re-index. It uses the endpoint broker index policy full. Partial or catch-up indexing only indexes nodes that have not already been indexed. It uses the endpoint broker index policy partial. None of our nodes have been indexed thus far, so let's use full indexing. So we'll copy the broker index policy full endpoint from the doc site and paste it into our terminal. After indexing, our data is searchable. Now you can head over to the movie database project that we created in the dashboard in the movie database tutorial. You can now search for person and movie nodes and get back the default information from our generated index policy. Searching is also possible through the search all endpoint, which I'll go over during feature 2. To recap implementing feature 1, first we generated an index policy using generate custom index policy, we then saved that policy with save index policy, and last we indexed our data with broker index policy full. There are some more search query examples to try out on the doc site if you're interested. We still have one last feature to meet. Feature 2. Searching the title of a movie like The Matrix should return the movie along with all associated people. To meet feature 2, we'll go into more depth about index policy customization. Index policies are highly customizable, giving fine-grained control over what gets indexed. Search leverages GQL queries inside the index policy to retrieve targeted information about your data. Queries in the index policy should be written from the perspective of the node being indexed, also known as the anchor node. To implement feature 2, we'll need to update the policy schema to include a list of movies each person is associated with under the person index. This can be done by adding 2 custom index schema properties. The first property we'll call acted in. It'll look for an optional match of a relationship of acted in between a person and a movie node, and then collect the value of the movie node's title property. The second property we'll call directed. It functions similarly, but instead of looking for an acted in relationship, it looks for the relationship of directed between a person and movie node. So we'll need to update our index policy to include these properties under our person index. If you need help figuring out where to put these additions into your request body, head over to this link provided in the tutorial. It will take you to a page in the Search API docs that talks more about schema and how its properties are defined within the request body to create or update an index policy. But to make things easier for this tutorial, we have the entire curl command with the updated schema properties here that you can just copy and paste into your terminal. After updating our index policy, we need to re-index all of our nodes. We can do this by running the broker index policy full request again. After re-indexing, we can check the feature 2 has been met by running the search all endpoint and passing in a parameter of Keanu. Our request returns one person node belonging to Keanu Reeves along with our properties of directed and acted in. You can try out some more queries by using the examples on the doc site. To recap what we did for feature 2, first we added 2 schema properties called acted in and directed under the person index using GQL, then we saved our index policy changes with a save index policy endpoint, and re-indexed our data with a broker index policy full endpoint. Let's move on to our last topic of continuous indexing. Let's look at a case study. Let's see what our search results do when we update information without having set up continuous indexing. We can update the year that Keanu Reeves was born in ONgDB. You can get to ONgDB by going to localhost at port 7474. You can copy the exact GQL that I'm using from the doc site and paste it into ONgDB. We can check the node properties and see that his birth year has been updated. Now let's check if our search results have also updated. We can see from the results of the search all query that the birth year did not update. This is because our index data is out of sync with our graph data. We can get changes in sync by applying a continuous indexing trigger. To apply a CI trigger, we'll run the RabbitMQ continuous indexing trigger endpoint. You can ensure that CI was successfully applied by calling a list of all triggers in ONgDB. You should see a policy by the name of Default Search Index Policy Continuous Indexing. Because CI is a trigger, only new or updated data on the graph becomes immediately searchable. This means we need to update Keanu's birth year again for this example to work. So we'll update Keanu's birth year again. Once again, you can copy the exact GQL that I'm using from the doc site. And we'll double check and the node has been updated. And now for the moment of truth, we'll search Keanu again using our search all endpoint. And thanks to continuous indexing, we'll see his updated birth year in our results. And that will do it for this video. Make sure to look out for our Show Me Basics tutorial, which is coming up next. In the meantime, you can head over to the GraphGrid community subreddit. There you can ask questions, discuss the platform, or chat with other members in the GraphGrid Lounge. You can also join our community on Discord to chat live about the platform, or follow us on Twitter to get notifications about new content and platform news. And last but not least, subscribe to us on YouTube. That'll conclude it for this video. Thanks for watching, and happy graphing!